Now, this little video will have a couple of little exercise examples that I've taken from the Edexcel Mechanics 3 textbook by Pearson, and I'll just go through them. One's easy and one's more difficult, but it still uses the same technique. Now, in the first video that I made, we looked at the idea that the integral of f of x dx was equal to half v squared. Okay, so that's the idea that I'm going to be using now. Okay, so here we have a predefined acceleration given to us in the question, and there are a set of initial conditions given as well. So half vx squared is equal to the integral of the function with respect to x. Done. What do? I integrate. So I integrate. Don't forget the constant, because the constant you're going to need to find out using the initial conditions. And I get that v squared is 4x plus x squared over 2 plus the constant. So when I set time equal to 0 and v equal to 5, I can continue. Okay. Now, it may be tempting to say, well, what's v? Okay, and then go, let's square root all of this. Don't. Okay, leave it with v squared. Okay, and you can see why in the next little question. So this question, a little bit more difficult, but only because it's a slightly more difficult function. Still just integration. So the same idea, half v squared is equal to the integral of the function with respect to x. Obviously I've changed the function into something that's a little bit easier to integrate, less chance of mistakes. So I integrate, get a nice simple answer, get a constant, and then I get rid of my factor of a half. Now, using the initial conditions given me in the question, I can say, okay, what's the constant? Now, I've not gone for v, I've kept it at v squared, which means that I do need to square this. Okay, substitute everything in, and I find my constant. Easy enough. Now I've found my constant, I have a nice little term in v squared, and if you notice, they're all squares. Okay, so I can factorize this, and when I factorize it, I get a nice set of double brackets. Okay, so that becomes very easy to square root. Just get rid of the square, and that leaves me with the value for v at the end. Continue with the second part of the question. Okay, find the minimum velocity. So to find the minimum velocity, at a minimum velocity you've got a turning point, so the acceleration is equal to 0. So I'm using that fact and my initial acceleration to find out where. Okay, very simple. Okay, if you look at the steps, I just have different values. Okay, now I get a final x value here. This final value for x, root 2, can then be substituted back into my equation for v. Okay, so I substitute it in and I get this as my answer, which obviously can be simplified to give a final answer. Okay, if you found that difficult, look over, try and see what I did, and go back to the first video as well, possibly. Okay, good luck.